Good day, learners. In this lesson, you will be able to learn about endogenic processes. Are you ready? Let's learn. Our lesson objectives are to describe what happens after the magma is formed through plutonism and volcanism, and describe the changes in mineral components and texture of rock due to changes in pressure and temperature, also called as metamorphism. To begin, let us talk about endogenic. When we say endogenic, that is geology formed, located, or occurring beneath the surface of the earth. Therefore, it does not occur on the surface of the earth, but beneath on the surface of the earth. We can divide the endogenic processes into five major things. First one are the heat in the earth's interior, the folding and faulting, magmatism, metamorphism, and volcanism and plutonism. To begin, let us talk about the heat in the Earth's interior. There are two main categories of heat: the primordial heat and the radioactive heat. The primordial heat is the heat that comes from the history of the Earth on the clashing of heavenly bodies and even on the occurring heat that the Earth or planet is still suffering from primordial materials, while the radioactive heat refers to the radioactive material that our core possesses to create heat on Earth. The question is how the Earth's internal heat is being distributed. In able for us to answer it, we need to consider convection and conduction. This concept is not new to you. When we say convection, it is when a fluid such as air or liquid is heated and then travels away from the source. It carries along with it the thermal heat energy, and with that so, heat is being transferred. This is called convection, as being shown on the picture. We can also have an analogy of it as we cook on our pot. Convection happens and conduction happens as radiation and heat is being emitted from our stove. The same scenario happens on the mantle of our planet Earth. On our planet Earth, convection cells and convections happen, extending even into the crust of the Earth. The second one is the folding and faulting. First one to discuss is all about the folds or the folding. A folding or a fold may be created when two forces push towards each other from opposite sides and the rock layers will bend into folds. It is simply called as fold because it looks like a real fold. The process by which folds are formed are due to compressional forces known as folding. A very good example of that one is expressed in this picture, where there is a fold center where compressional force is being highlighted. We may also have that one through the types of fold in this picture. There are types of folds such as syncline or the downward curve of fold and the anticline, which is the upward way of the fold. Compressional folding or compressional tension will give you these kinds of fold. The second concept is all about faulting. This way, faulting is the fracturing and displacement of more brittle rock strata along a fault plane, either caused by tension or compression. A while ago, folding is mainly caused because of the compressional energy. But this time, faulting can be expressed and may occur due to tensional or compressional energy. This is where there is a break in rock along with a vertical or horizontal rock movement that has occurred, which we call that one as fold or fault. The processes of forming a fault is called faulting. Now, there are types of fault being expressed in this picture. The first one is the normal fault, the second one is the reverse fault, and the third one is the strike slip fault. When we say normal fault, the foot wall is being uplifted while the hanging wall block is going downward. There would be a outward movement between the two blocks, so resulting our footwall to uplift and our hanging wall to go downwards. The second one is the reverse fault. The reverse fault is where the hanging wall is being uplifted while the footwall goes downward. This one is being resulted due to compressional tension. The third one is the strike slip fault, where there is only sharing side by side movement of a particular fault. Now let us try to twist your brain by understanding and analyzing these activities, these real life activities. Let us identify what type of fault is this one. Well, if you have said normal fault, that's correct. It is very evident that on the left side, the hanging wall went down on the right side while the footwall is going upward, resulting to a normal fault. Very good. How about this one? Well, if you have answered strike slip fault, you are correct, as there are only side by side movement of two layers of rocks here. How about this one? Still the same. This is a strike slip fault. Strike slip fault because there is only a sideways movement of two major blocks. Very good. You're really good in answering the questions. Now let's move on to another endogenic processes, which is magmatism. Magmatism happens when there is a magma generated and develops into igneous rocks. Now, this picture shows how igneous rocks are being created. There are intrusive igneous rocks and extrusive igneous rocks, which will be discussed later on. So, this is how the partial melting of origin of magma happens. The magma rises, it undergoes intrusion, underplating, stagnation, and crystallization, having the magma differentiation in magma reservoir. And when it goes up, it erupts into a volcano or into a volcanic eruption where extrusion of lava happens. And also, not forgetting that there would be volcanic gases that will be mixed with the atmosphere. But I just want you to focus when magma generated to develop an igneous rock. The next one, by the way, we would like to know where the magma are being formed. We have three good examples here, which are on the mid-ocean ridges, the mantle plumes, and the subduction zones. All of these are being discussed by your grade 10 teacher already. Now let's move on to the plutonism and volcanism. To begin, we have here a very destructive volcanic eruption. This is a real volcanic eruption and was taken by Albert Garcia way back June 15, 1991. So it will only tell us that plutonism and volcanism can be very destructive. To begin, let us talk about plutonism. This is where the formation of intrusive igneous rock by solidification of magma beneath the Earth's surface. As you can see on the picture, there are subchambers of magma over here, maybe due to lack of high temperature, but still on the same pressure. The particular magma here cooled down as the temperature is also lowered to its original point, creating now our intrusive igneous rock. Therefore, plutonism is the formation of igneous rock beneath the Earth's surface, and we call that rock as intrusive igneous rock. The second one is the volcanism. The volcanism is where there is a formation of intrusive igneous rock by solidification of magma beneath the Earth's surface. So earlier we have known about the intrusive igneous rock formation. Now this time let us talk about volcanism. The volcanism is the phenomenon of eruption of molten rock or magma onto the surface of the Earth or a solid surface planet. This time, there would be extrusive igneous rock that are being formed as these magma is transformed into lava, and the lava is being cooled down, creating now our extrusive igneous rocks. So this is a very good example of the volcanoes having magma into it. The next endogenic processes is the metamorphism. When we say metamorphism, this is the process of changing materials that make up the rock. The chemical components and geologic characteristics of the rock change because of exposure to heat and pressure. This time, heat is not only considered but also exposure to high pressure. Now, there are types of metamorphism as shown. We have here the regional metamorphism and the contact metamorphism. Now, what are the stresses that influences the rock behavior? We have four major rock behavior that influences it. The first one is the compression. The compression is where the rocks push or squeeze against one another, where the stress produced is directed towards the center. To understand it more, it seems like the rock is being compressed, pushed against each other to create rock together. The second one is the tension. The tension is where the rocks pulled apart and where the rocks may separate in opposite direction. It seems the pulling of a particular rock away from each other. So it seems like it's a divergent rock. The third one is the shearing. The shearing is some of the portion of a plate at the edge may break away in different direction, eventually making the plate smaller inside. So in able for you to understand it, we have here the shearing. It is where the side-by-side movement of the rocks are being created. Now, the last one is the confining. The confining is where the crust becomes compact, thus making it look smaller. Now, compared to shearing, the shearing do only have two directions in different ways, while confining is where all the directions are compacted into a rock, creating here a confining pressure. Now, this time, let us twist your brain through this activity. Let us identify the type of stress. What do you think is this kind of stress? If you have answered shearing, you're correct because they are only a side by side movement of the rock over here. How about this one? Identify what type of stress. Very good. That is tensional since this two direction are going away to each other, creating a crack on the land. Very good. Now about this one. Yes, if you have answered compressional stress, yes, it is, because it is very evident that these rocks undergo compression because of this formation. Now, you may extend your knowledge by viewing the PDF form or the PDF file that we have uploaded in MCM Digital. Also, the rocks on igneous and metamorphic are being discussed over there, and you may comprehensively check how these rocks are being identified. Now that's it. Thank you very much for listening. Hope you have learned in our video for today. Have a great day and enjoy learning.